Screen sharing is on. Yes, hopefully. Okay, so this is activity 3-2B about subtraction with base 10 blocks. And you can draw them or you can do screenshots of either the Cool Math for Kids app, which we used early on, or the Math Learning Center, which we've been using for the last week. And I've decided I like the Math Learning Center one because you can share what you do, which is kind of fun, and you can write all over it. I give an example up front of what does 36 minus 23 look like. And here I'm talking about takeaway, but I'm kind of showing a comparison picture because I put one on top of the other. Here it is where I'm showing comparison, where I actually start with both sets. So that one looks similar but different. And then I have a bunch of problems that I want you to try, like show me what it looks like for 47 minus 24, for 32 minus 17, for 31 minus 14. And I'm adding a slight extra thing. I had talked about this, I didn't write it down earlier, but can you write a story for each of these? Can you think of a situation that would be a takeaway for 47 minus 24? Can you think of another story that would be a comparison of 47 to 24? To get the answer. So for each of these problems, 1, 2, and 3 things are going to happen. You're going to show me how to do it with base 10 blocks, and then you're going to tell me a takeaway story for it, and you're going to tell me a comparison story for it. Okay. And then I give another example down here of 35 minus 27, where I show my trading 110 for 10 ones. So kind of like I was writing before. And I also did another one on paper. So this is me drawing it on paper. I'm a little better on paper than I am with those magic pens I've been trying to draw with lately. All right, so that's the activity. It's like what we were doing in class today. We're trying to model what subtraction means. Those models can either be takeaway models or they could be comparison models. For this, I want you to show both takeaway and comparison for each of those with pictures. Questions on what I'm hoping for there? Okay, did anything come up in the chat? No, okay. So, oh, how do I get the chat to go away now? Zoom is not my friend today, you guys. My chat screen is in the way. What does it look like for you guys? Is there a big blank box in the middle? There is. That's annoying. There we go. All right, let's take a look at the homework then. So hopefully you started working on the homework already. And maybe you finished it, maybe you get stuck on some problems. I only got a couple of questions so far about the homework for 3-2. Some of them are pretty straightforward and some of them are a little trickier. Let's see, the ones I did, I think the ones that were trickier. So let's jump down to some of those. So that was the addition model for greater than and less than. We talked about that today, so similar problem. 13 is what compared to 9, and so we have a few options, less than, equal to, or greater than, and we would select greater than, and the reason why is that 13 is equal to 9 plus, what would this be, 4 here. So that's one of the definitions in the book about what it means to be less than or greater than, that we have to add something to one of the numbers, the smaller one. And so that's what I'm hoping for from that problem for you if it wasn't entirely clear. Let's look at some other ones. Oh, the dot one. Yeah, let's do an example of the dot. So I did this in the beginning of class. So let's get a new one. So the dot method is like the scratch method. I put a dot every time I make a 10 and I keep track of the ones. So let's blow this up a little more. Can't get much bigger than that though. So 6 plus 1 is 7. I just keep that in my head. 7 plus 8 is 15. So I make a dot and I keep track of the 5. 5 and 5 is 10, so I put another dot, which is just a period. So I have no ones. So I have 5 now, 5 and 6 is 11, put a dot, keep track of the 1. 1 and 4 is 5. 5 and 8 is 13. Put a dot, keep the 3 in your head. 3 and 3 is 6. No dot because I didn't make a 10. I put the 6 ones down here. And then the dots tell me how many 10s there are. So I have 1, 2, 3, 4. So this must be 46. So here I'm just keeping track of whether you put a dot or not when you found a 10, and do you have the final number right? Okay, so every time we find a 10, we put a dot to keep track of it, and then we keep track of the ones in our head. Alternative to that is where we actually, let's see, that's, oh yeah, this is the one I want to look at. So this one uses the other version of the scratch method, where we actually write the ones digit too. So 1 and 5 is 6, 6 and 6 is 12, so I go scratch 2 for the 12. And then I only keep track of the 2 now, because I have the scratch there. 2 and 5 is 7, 7 and 2 is 9, 9 and 9 is 18, so I would go scratch 8. Keep track of the 8. 8 and 7 is 15, scratch 5. 5 and 5 is 10, scratch 0. 0 and 3 is 3, just write the 3 below, and then count your scratches above. So this would be 4 scratches and then 3. Usually I do these on paper and then come here and try and put it into the computer like I did in the beginning of the class when I did the scratches on paper. Let's see, this was just a repeat of that problem for the next one. Okay, so this one I didn't talk about yet, but there's fact families that are involved when we do addition, subtraction, multiplication, and division. And any particular addition, subtraction, multiplication, or division problem is part of a set of 4. Okay? So for example, 23 plus 7 equals 30. There's actually 4 members of this family right here. So I'm gonna put it in my notebook and then come back here. New page, if my pen still works. Oops, still working. All right, so what was it? 23 plus 7 equals 30 was the original. The related addition fact would be 7 plus 23 equals 30. Subtraction facts would be 30 minus 7 is 23, or 30 minus 23 equals 7. So what we get is this family of 4. They're called fact families. For any particular problem. And so in that question, I was just asking you, hey, what are some subtraction facts that mean the same thing as this? So I would enter 30 equals, 30 minus 7 equals 23. And then 30 minus 23 equals 7. And it doesn't matter which order you enter them in. You could have done the 30 minus 23 above, and it should work out okay. All right, let's see. There was some other where we do the algorithms. So this is about the number line model. I thought those were pretty straightforward. You could message me if you get stuck on them. Okay, so here's one involving the complement method. So just some terminology that goes along with this. We haven't talked about that, but it's in the book. When you subtract, you have a minuend and you have a subtrahend, okay? So in this case, the subtrahend is the 266, the minuend is the 639, and when you point to them, they tell you what they are, if you weren't sure what those phrases meant. Complement is always from the bottom number out of whatever the next place value is. Since this number is in the hundreds, the complement is out of 1,000. And remember, to make a complement, the first digit has to make a 10. The other 2 digits have to make 9s. Okay? So if I was making the complement here, for the 2, I want to make a 9, I need a 7. For the 6 in the middle, I want to make a 9, so I need a 3. And then the last 6, the 1's digit, that has to make a 10, so I would need a 4 there. So 734 is the complement of 266. And then what we do is we take that complement and we add it to the top number. So that's what the next part says. Find the sum of the complement and the minuend The minuend is what's being subtracted from the 639. So what's 639 plus 734? So let's see, what do I get there? 9 and 4 is 13, carry the 1. 3 and 3 is 6, plus 1 is 7. And then 6 and 7 is 13. And then I just remove the extra place value, which is that 1,000 out front. So the answer should be 373. You can always double check that using the standard algorithm on 639 minus 266. That should be the question. That should be the result. So here's where you get to practice you doing the complement method on the computer. And I highly recommend you write it on paper. I just did all that in my head. Put it on paper. Good idea. All right, I think we got time for one more. It's another complement method. Okay, so this one was a little weird. This is going to do the left to right method. And I'm going to draw it on paper, and then I'm going to come back here and show you how I would put it in there. So with the left to right method, we borrow from below, and we're going to use an underline when we have to borrow from below. So let's see, this is 3999 minus 6532. 3999, 6532. Oh, something's wrong there. I read that wrong. Oh, plus, right, I'm doing plus. Why was I thinking subtract? Plus 6532, that makes more sense. So we're going to do this left to right, which is also called the Hindu method. So 3 and 6 is going to give me 9. So I put that there. And then 9 and 5 is 14. So I put the 4 there and I carry that 1 over to give me a 10 there. And then 9 and 3 is equal to 12. So I put the 2 there, carry the 1 over there for a 5. So these scratches here are going to turn into underscores on the other in the program. So then I have 9 plus 2 is 11. Scratch that 2 out, add 1. So that's going to be a 3. So the answer should be 10,531. Alternate view of that with the underscore instead of the slashes. Would look like this. And this is how you're going to enter into the computer. 3 and 6 is 9. 9 and 5 is 14. And so we're going to do underscore 10 like that instead of the scratch. 9 and 3 is 12. Put the 2 underscore. That 1 bumps that 4 up to a 5. And then 9 and 2 is 11. The 10 from 11 bumps that 2 up to a 3. So put an underscore, and then the 1 is going to be there on the answer. So that is an alternate of the scratching with Hindu. Instead, we're going to do underscores so we can enter into the computer. And that's what I would transfer into the computer. So I'll show you that on the computer entry box. So starting on the left, 3 and 6 is going to give me a 9. So I just put the 9 there. And sorry, I meant these to line up, but it didn't quite happen. 9 and 5 is 14. So I put the 4 here, and then underscore here, and then the 10 from the 14 bumps that 9 up to a 10 over here. And there's a video of me doing this here too. 9 and 3 is 12, put the 2 from 12, the 10 from 12 jumps to this column, making that 4 or 5. 9 and 2 is 11, the 1 from 11 goes here, the 10 bumps that 2 up to a 3, and then drop the 1 in. So that's left to right method using underscores. Ooh, got it right today. Okay, we are about out of time. Does anybody have any questions?